Welcome to my talk today about converting a Java desktop application to Kotlin Multiplatform. I'm gonna have to disappoint you right on the second slide, because the second slide is, after this awesome animation, why I did not succeed. I'm sorry. I know Angela Merkel is disappointed with me as a German. I get it. This talk is like about lessons learned, about things I did wrong, mistakes I made when trying to convert my application to Kotlin Multiplatform, so you do not have to make those mistakes, those same mistakes. So yeah, before we dive in, I just want to briefly talk about Kotlin Multiplatform. What the hell is it? Why should you care? And where does it make sense to use it? Where does it maybe not? Which you will also see in this talk. So imagine you have your setup of applications, right? You have your product, and it's running on iOS, on Android, on desktop, on web, probably. And they're basically all doing the same. Some might be further in product development. Some might be just a bit behind. But in the end, they're mostly the same, and they share a lot of code, actually. A lot of code is just duplicate. So for example, your domain entities, right? A model describing a rabbit, because rabbits are awesome. You will have it in Kotlin in your Android app. You might have it in your iOS app in Swift. You might have it in your web app in TypeScript. But it's the same. And having that code duplicate is totally fine, right? But if you get to designing and developing a product which is more complicated and more complex and has maybe some complex math, for example, going on, something like this, with this being 1% of the math that's going on in your application, and you're gonna have to re-implement it across every platform, it's not gonna end up scaling well, because on each platform you're gonna have to make sure that everything works. Still, you're gonna have to write tests, and if something breaks on one platform, you're gonna have to repair it, and it's very, very painful. So what if you could just take that code and extract it to a common module? This is not a totally new thing or anything, right? This pattern has existed for quite a bit. Maybe you've used the Android NDK to share code using native libraries. But there are some problems with using languages like C++ or C# for this, because in our mobile dev environment, a lot of the times the developers just will not be that proficient in using languages like C++ or C#, and they will feel more comfortable in things like Swift or Kotlin or TypeScript or whatever is just closest to them. So we're going to take that principle with Kotlin Multiplatform, and we're going to say, all right, it's just the same thing, it's just Kotlin, so it can only contain Kotlin code. This is the case that we have with Kotlin Multiplatform. So you have your common module, it's only Kotlin, and it cannot contain any platform-specific dependencies. So that means it cannot reference stuff in the browser, it cannot reference any Java or JVM APIs, for example, Java Date APIs. So your common module should be there for containing data models, domain entities, or just very heavy business logic, which makes sense to share. Do not overdo this. Do not go crazy and say we have to push everything into the common module. But take it slow, go step by step and convert what you can. We'll take a look at how you could do that in a second. So Kotlin Multiplatform introduces a new syntax. It introduces two new keywords, which are expect and actual. So in your common module, you can define a val. You can define a val or a var or a function or a class or an interface as expect. That is your way of telling the Kotlin compiler, all right, I expect this to be there, and I'm pretty certain it'll be there. Hopefully it'll be there. And then in your platform-specific modules, for example, JVM or JS. You can define your actual implementations of that. So in your JVM module, you could have this actual val platform equals JVM, or on JS, it's set to JS. So if you go back to your common module now, where you have defined, all right, we have this expect val platform, and we know this is going to be there, then you can reference it in your common code without having this very platform-specific thing. This is super nice for just abstracting and telling Kotlin this will be there. The Kotlin compiler ensures that this stuff is actually there at runtime by running a compile time check. So if you say, all right, I have this expect val, but I have not provided any like actual value for it, then the Kotlin compiler will complain and will say, hey, you have to provide this for me to work, which is a good thing. So you will not run into any weird runtime errors. All right, hard words. Now, since I was mentioning that the common module can only contain Kotlin code and no like JVM or platform-specific dependencies, I just want to talk about getting rid of Java dependencies real quick. Java dependencies are kind of everywhere when you're coming from Android development, right? You probably know the Java date and time APIs. You might have used like something like random. You might be using Moshi or JSON or retrofit or like anything really. A lot of it just depends on Java specific things. So what can you do? Well, there's a few cool libraries which can help you with that. For example, there's Clock, which is an open source library on GitHub, which is really nice. It is multi-platform and it does not depend on any like Java specific stuff, which is super awesome. For random right now, there's a key P going, so a Kotlin enhancement proposal, which will be hopefully implemented soonish. And if you're looking for something about serialization, there is Kotlin Access Serialization. So it's multi-platform, and you can easily use it just anywhere. It's pretty similar to JSON or Moshi, just the difference being that the error messages are just a bit less descriptive. If you're coming from Android, you're probably using retrofit as well. And if you're looking for a good HTTP client, which is usable on multi-platform, Ktor is super awesome. There's many more libraries out there. Keep an eye out for what Ryan Hodder will be publishing soonish, maybe, about reactive stuff. And well, the lesson basically is there's lots of stuff from the community out there which you can use. The tools are a bit different, but most of the time they're very similar. So now we've got that out of the way, let's talk about like actually getting started. And like getting started, it's super easy. It's like 2 slides. It's really as easy as opening up IntelliJ and hitting new project, and you get to this wizard and you can like select, all right, I want a Kotlin Multiplatform module. And then you could like also go for Kotlin/JS, and you can also have a Kotlin JVM module. And you can even opt in for like a Kotlin Grail DSL script, which is super awesome. You can also stick with Groovy, but I've been using the Kotlin DSL in preparation of this talk, and it's been working super awesome, which has surprised me, but it's been very stable. So once you get through the wizard and wait for the Grail build to finish, I'll stand here for 2 minutes. This is what you will get. So there's a bit of stuff going on, but let's focus on the important stuff, which is in the source folder right now. Since we only selected the Kotlin Multiplatform option in the wizard, there is common main and common test as a module. So those contain your common code. Now we could also like go ahead with file new module and add JVM and JS modules. We don't care about that for now. We also have the Gradle script, so let's take a look into that. It's really not as intimidating as I first thought it would be. It's limited to just like defining a dependency on the Kotlin Multiplatform plugin, defining the version, obviously, and that's it. That's what you need, basically. And then you have the source sets. So let's take a look at the source sets, because the source sets are kind of the essential way for getting dependencies in if you don't have like individual build.gradle files for each module. So with that, just like one top level Gradle file we have right now for the project, we can access the source sets like common main and set the dependencies. Notice here we're using the standard library common, which is a common version of the standard library. If you're looking at the standard library for JDK, you're seeing, or for JVM, you'll see that there might be some Java references somewhere, especially concerning collections. So the common standard library is something you'll have to use if you want to target multiple platforms, because that provides some abstractions and re-implementations of that. Now, you can also add like the Kotlin test common dependency. This is really just an easy way of getting to the source sets and configuring them. You can do anything in those blocks that you want. Now, this talk's title is converting a Java desktop application to Kotlin Multiplatform and why I failed. So let's talk a bit about the existing application. How many of you here are Android developers? Okay, cool. How many of you have heard of Motion Layout? That's nice. Okay, so if you haven't heard of Motion Layout, it's a tool for making animations and transitions easier. I'm not gonna say easy, because easier, because they're quite hard on Android. And basically, it has a feature which is called key cycle. If you wanna have an animation for, let's say, a button, and you make it shrink and grow and shrink and grow and shrink and grow again, you'd have to define that like 3 or 4 times, which produces like 60 lines of code probably. And if you could just reduce that down, that would be really, really nice. So they introduced a feature which is called key cycle. So if you look at like the value of the size of a button like shrinking and growing, you'll see it's like it's going up and down and up and down. It's like a wave. And as you can probably hear from this explanation, this is like kind of hard to imagine sometimes if you're seeing it in code, right? Imagining what the animation looks like, you have to be pretty smart for that. And I am not, so I appreciate this feature. And they realized that, and they created a tool which is called Cycle Editor. So basically, it just allows you to preview the animation of that key cycle, which is super awesome. And this application is written in Java. It's using Swing and AWT, and it's, let's say, prototypey. And as we will get to see, the architecture is kind of all over the placey, but that's fine. So I was looking at the project and I was like, okay, right, that looks kind of fine. I mean, like 12, 15-ish files, that's cool. I can just like convert each of those to Kotlin. I'll be good, right? Yeah, I'm fine. And then I opened up main panel.java and it was like, PowerPoint crashed multiple times during adding that slide. Yes, this is my reaction. PowerPoint is crashing again now. All right. Because, you know, everybody knows that you have to separate logic from the UI, right? Okay, let's like kind of try to apply that. Because that is what I went for and did not succeed. So I was looking at the files that I had. And I was okay, I have like, I can split it up into 2 groups, like directly UI related, which is animation panel, cycle view, cycle edit, and main panel. That means that they're like directly referencing something from a UI framework, in that case Swing. So, for example, main panel and animation panel and cycle edit and cycle view, they're all extending from JFrame or JPanel. So, since that is like Java-specific code, that is not something you can really easily abstract. My first instinct, however, was to like go, all right, what can I do with that? Like extends JPanel, that actual expect thingy. What if I just were to like create an expect class JFrame in the common module and then like just provide the actual class, have it inherit from swing JFrame, so we can maybe do some custom stuff, and that's fine. It's not though. Once I actually tried to start build stuff, I quickly realized, oh, well, I was in the JavaScript module and I was like, well, now we'll have to implement JFrame and all the methods that are being called in it. I was like, okay, so I'm basically writing Swing UI in JavaScript. Is that what I should be doing? No, not at all. So I started off with a clean slate again. I threw everything away. I was like, okay, I'm accepting my fate. I cannot like reuse those components. That's fine. They will go into a platform-specific module. They will go into like the JVM or JS implementation, and that's cool. Now we got those, let's say, kind of sorted out with the status of, well, they have to be rewritten. There's nothing I can really do about it. And I was looking back at the other stuff that I had, and it was like, okay, looks like it's just like all modeled, kinda. So I was looking into the files, and it's like, all right, cycle model, cycle stat model, that's cool, sounds kind of good. There's no real presentation layer in there, but that's fine. So all that stuff, you can just pull it into the common module, right? Should be super, super easy. Then I opened up one of the files, looked at them, and was like, this class called a model had, for whatever reason, a reference to the main panel and a J text area, and then some other reviews and a lot of stuff going on mixed with business logic, obviously not making it testable, which is never nice. So I was like, okay, at this point, I don't think there is really anything I can do. That is the point where I kind of accepted my fate of this talk becoming a and why I failed talk. Because I realized that you actually have to have kind of clean-ish code with some separation of concerns for a Kotlin multi-platform to work. You have to just have some basis to start off with, which this one did not have. So if you are listening to this talk and thinking, okay, maybe I can convert my Java desktop application or like my Android application, my iOS application to Kotlin multi-platform, take a step back. Take a look at the architecture. Is it really actually flexible, or is it rather all over the place? How are the data flows coming along? So instead of like telling you what you should do, I'm gonna tell you kind of what you should not do. Number one, obviously, no UI dependencies in your modules. I mean, this is rather common knowledge, but obviously don't do it. Don't reference this because it'll cause you so much pain. If you're having this, just revisit what you're doing. Number two is aim for your logic to be pure. I found that when you're converting or trying to convert to Kotlin multi-platform, actually your life will be so much easier if you kind of try to adhere to the principle of pure functions. So just having one input and having one output, being really, really strict about it will make your life a lot easier. Now, let's just push the project aside for a second and pretend that we have our like common module and our business logic migrated to Kotlin multi-platform now, and the code wasn't as bad as it actually was, and you wouldn't have to rewrite the whole thing for it to work. I'm gonna go on with some more tips and talk a bit about architecture and how you can possibly implement it for you to have a nice life. So let's talk about the platform-specific stuff in a second. So if you're looking back at that code in the cycle set model, like, okay, right, that update fun, right? It's, just setting stuff and directly referencing stuff. That's not really nice. And I thought back to my project at work and I was like, what if we just were to introduce a state model, so that update function would just produce a state, just playing around with it. And so when I created a data class for the state, super easy, just contains 2 values. And then I made the cycle set model update method just return. Well, I made it a function and return a state. Takes the old state, does some logic, and produces a new state out of it. So there's not much of magic going on. And that is when I realized one thing that really, really, really helps with Kotlin Multiplatform is to reduce your entry points. That is not just about the models. Maybe if your model has 10,000 different methods which are producing some output, maybe you should just revisit your model, break it up more, and then come back to converting it. That makes the most sense probably. But I'm also talking about the view, because we've talked about common stuff, we've talked about the business logic, producing state, but what about actually view stuff, right? Because that's platform specific, and how do we get to it? So let's go back to our state. And suppose we have this thing called cycle view. And instead of just exposing all the members, we'll just reduce it down to one method, which is called render. So this is real MVI basic. You just create this one entry point and it takes a state. And then internally it does all the mutations on the UI. So for example, it might update the text or something. The important thing is it's only the concern of that view, and it it's not the concern of anybody outside of that. All right, so we have the UI invoking the model. The model produces a new state and passes it back to the UI. Now, how do we connect the dots back to what we had with Kotlin Multiplatform? So I thought about this, and the thing I came up with was that you could have your UI, your renderer, for example, just as expect. So having this in your common module, or in that case in my common module, allowed me to reference it there and use it there. And then on the platform-specific platform-specific implementations, I was just able to provide an actual class. And I was able to just have this inherit from JFrame. So, on JVM I can still use Swing, right? And migrating the UI I had before is super, super easy, because I'll basically just have to put stuff into the render method instead of directly mutating it. And then everything kind of stays the same, which is super nice. And at the same time, we maintain compatibility for multi-platform. So on JS, you could just go for something like this, an actual class home renderer. And then you're using document.getElementById to get the text. And that's working super, super well. You're doing platform-specific stuff, and most importantly, you're keeping the UI to native elements, which is super nice, which is what you probably should be doing in a lot of cases. Instead of trying to abstract the UI framework, just take away your common logic, your business logic, and have things like expect classes for renderers, for example. Now, using this, I just want to show you how easy and nice it actually is, because it literally, this is a very simple example. You just obtain the instances, obtain the new state, and you render it. And this is all in the common module, so it reduces a lot of the work that you would have to implement twice or thrice across several platforms if you weren't using Kotlin Multiplatform. Also, I really briefly want to take a look at conversion strategies. So Ryan was giving a talk earlier today, and once the recording is out, you should definitely watch it. It's called Effective Multi-Platform Architecture. But I really want to tackle that if you have an existing application thing. So imagine you have your existing application, and let's presume that you actually manage to kind of have some separation there. So you have your UI, you have your presentation layer, and you have your domain layer, which contains some business logic and maybe some repositories. So Brian was also mentioning this, the repository is something that talks to database or maybe talks to an API. And you probably don't want to push this into a common module. You can, but you don't have to, because on Android you might find it nicer to actually use retrofit. There might be some platform-specific stuff when making connections to web services, for example. So this is stuff you can definitely just keep implementation specific and use expect functions, use expect classes, expect interfaces for the repositories, and then have the implementation per module. The important thing is probably that you're able to just push your logic into the common module. Your heavy calculations, math that may be going on, you'll be able to reuse that across different platforms. With that, let's just pretend we managed to convert a desktop application to Kotlin Multiplatform. It will still be working on this thing, and I hope that maybe one day I will be finished rewriting that. Maybe I will be. So look out for it on Twitter. The slides for this will be published on SpeakerDeck later on, and I'll be writing a blog post in the next 3 weeks. So definitely look out for that about Kotlin Multiplatform. If you have any questions, feel free to come up to the microphone or just talk to me after the talk. Thank you.